Plasmon Polaritons. What are they? How do we get them? That is relatively simple to answer. What we basically do is, if we have a metal, we assume that we can that we have conduction electrons, which can be modelled as an electron gas. Now, one of the things we can find is that the behaviour of an electron gas is very similar to that of a plasma gas, especially when it comes in relation to the interaction between the electron gas and light or electromagnetic fields. Now, what happens if we apply an electric field to an electron gas is that the electrons reorganize themselves to cancel the electric field. And in the case of an oscillating electric field, they too will oscillate. If we can find the right frequency at which these electrons oscillate, in other words the resonance frequency, we can refer to this, which is referred to as the plasma frequency. Now, when we oscillate the electron gas at this plasma frequency, what happens is we actually get a longitudinal wave propagating through the material. As we increase the frequency of the light, obviously the resonance effect decreases, but we find if we increase it a lot, then the effect of the electrons is essentially non-existent, and the light can pass straight through the metal. If we are below this plasma frequency, we are actually unable to penetrate into the material because the electrons are able to rearrange themselves quickly enough to be able to cancel out the electric field of the incoming light. Now, what can happen though, if we look at an interface, say, between a dielectric and a metal, is that we get what's called surface plasmon polaritons, and these are basically the polaritons that are there due to an evanescent wave. And this, what we have again, is this oscillating electromagnetic field, which on the surface creates groups of charges which themselves will oscillate with the field. And because this is on the surface, we have no propagation into the material, and they also serve to ensure that the electric field inside the material is zero. This doesn't work again if the frequency is too high, because we no longer get the evanescent field, we simply get the light transmitted. The final point where we can use plasma polaritons is when we take a very small metallic object which is smaller than the wavelength of light. Now, in this case, what happens is that our electric field creates essentially induces a dipole into the object as the electrons align themselves with the electric field. And because the object is much smaller than our wavelength, we can essentially just imagine it as a large-scale electric field, which we then apply an oscillation to. And this can be modelled as a dipole oscillation. The oscillation of the charges can be modelled as a dipole oscillation, which could potentially be used to allow near field effects to be detected in the far field by exciting one of these nanoparticles. So that's Plasmon Polaritons, and